Hello, I'm Benjamin Gansa, and I'm making this presentation on building and inserting into an R tree using the quadratic split. And I'm making this presentation as part of your spatial data structures. So what is an R tree? An R tree is a type of data structure used to store geometric shapes like rectangles, cities, regions, or polygons on a map. And it quickly helps to search for which shapes intersect or fall within a certain area. And this is very useful for applications like Google Maps, GPS, and then geographic databases. So, for example, if you are finding all restaurants within 5 miles of a particular point, or loading only visible map tiles or indexing boxes for a fast spatial queries, an R tree can be used. So for this study or this assignment, the objective was to generate 100 random rectangular shapes and then insert them into an R tree using the quadratic split and then display them graphically and show how the tree adapts when it grows. So what are shapes? Okay, so each shape is a randomly created rectangle. It has a left, bottom, right, and then top boundary. And these are called the bounding box, okay, of the tree. And they are like small patches on a map that the R tree needs to organize. So for example, as it can be seen on the right, the R tree, these are organized shapes. Then how is the R tree built? The R tree starts with an empty node, and then as we add rectangles, each one finds the best spots in the tree where it fits with the least stretching. And then when a node gets too full, it splits using the quadratic split algorithm. And this process continues as more objects are inserted. So the quadratic split that I mentioned, what is it? So quadratic split looks for the worst pair of rectangles that are far apart and then puts them in different groups. And then it assigns the rest of the rectangles to whichever group that fits better. And this is called quadratic because it compares every pair which takes more time but gives a better balance. And this is the code that I implemented for the quadratic split on the right. Then next step is the object generation. And then the first part of my code creates the 100 random rectangles using the random model. And each rectangle has a random position, that's the XY, and then as well as a random width and height. And this was implemented using the random model, which was implemented in the Python code. Then the next step is the creation of the tree node structure. And then each node in my R tree holds a list of rectangle entries and then possibly child nodes. And then the flag to say whether it's a leaf or, that is a bottom level node. And then the node has a function to calculate its bounding box from all 8 entries. And then on the right is the code that I implemented for the tree node. And then we go to the insertion part. And then to insert a rectangle, first, just find the best leaf node to place it and then add it to that node. And if a node is too full, it split it. And this splitting goes up to the root. A new root is created. And then the tree grows upward. And all of this happens automatically as we insert each shape. And on the right is the code that I use for the insertion. So finally, when everything is inserted, you can visualize the boxes, irregular boxes. And this is on the right is shown, the 100 irregular boxes that are generated using the code. And then the code for the visualization is also on the left. So finally, in conclusion, the R-tree structure that I created successfully indexed 100 spatial rectangles, and then each node dynamically adjusted its consent through a quadratic split. And then the resulting structure was visualized, and then which confirmed the rectangles were correctly generated and stored, and then spatial boundaries were respected. And then the tree handled insertion and then growth autonomously and then correctly. So ultimately, the project demonstrates that our tree are highly effective for spatial indexing, and they can be adapted to scale while keeping search for minimal areas. And these are some of the sources, not all, but then some of the sources are used for implementing my code. Thank you.